The action of heat on materials. Heat is a form of energy. Energy is a capacity to do work. The Earth's main source of heat is the sun. Man can make his own heat by burning fuels like wood, kerosene, and gas. The Bunsen burner. In 1852, Robert Wilhelm Bunsen became professor of chemistry at the University of Heidelberg in Germany. One of the many important things he did there was to invent an apparatus that would mix gas and air in just the right amount to give a hot, clean, non-luminous flame. It does not produce soot or smoke. When you use a Bunsen burner, remember these points. Before you light it, close the air hole. Get a lighted match or flame ready. Next, turn on the gas and light it. Then open the air hole. When the air hole is fully open, the flame is very hot and noisy and nearly invisible. It is called a roaring flame. The blue cone in the middle of the roaring flame is gas that has not yet burned. The hottest part of the flame is just above the blue cone. When the air hole is closed, the flame is luminous and sooty. So, always have the air hole open or half open when you are heating something. If you are not using the Bunsen burner for a while, close the air hole so that the flame is luminous and can easily be seen. This may prevent an accident. Heating things in a test tube. When you are heating a solid in a test tube, remember, always use a test tube holder. Always wear safety spectacles. Always hold the test tube at an angle. Never look down the test tube or point it at anyone when you heat a liquid in a boiling tube. Do not put too much liquid or it will boil over. Add a few anti-bumping chips to make it boil smoothly. A flame may be luminous or non-luminous. A luminous flame gives out a yellow light because tiny particles of hot carbon glow to give out yellow light. A non-luminous flame is formed when the fuel gas is mixed with air before it burns. This mixture burns quickly and completely, producing no carbon particles. A non-luminous flame is blue, steady, noisy, and very hot and produces no soot. It does not dirty laboratory heating equipment, which are quite often made of glass. Physical changes. Sulfur is a yellow solid which melts to form an amber liquid. The liquid finally burns to give off brown sulfur vapor. The vapor condenses and eventually solidifies to give back yellow sulfur on cooling. Sodium chloride melts at temperatures higher than 800 degrees centigrade. The liquid solidifies to give the solid. Platinum, nichrome, and tungsten wires glow white hot on heating and change back to their gray color on cooling. Iodine, camphor, and ammonium chloride are substances that sublime on heating. The solids change their states directly into gases without passing through the liquid state. White sugar melts, turns yellow, then brown. Chemical changes. Most simple substances, that is elements, combine with oxygen when heated in air. The products formed on combination weigh more than the starting elements because oxygen has added to it. Carbon burns in air completely to give carbon dioxide. Sulfur burns to give sulfur dioxide. Hydrogen explodes in air and burns in oxygen to give water. Some complex substances like candle wax, coal, kerosene, alcohol, and wood burn when heated in air to give out light and heat. They also give off carbon dioxide and steam. Some solids, that is compounds, decompose or break down when heated. Their products of decomposition are not easily reversed. White sugar melts, turns yellow, then brown. Finally, it decomposes to give black solid of sugar charcoal, and steam is given off. Wood, paper, animals, when incompletely burnt, black charred solid is left and steam is given off. Blue hydrated copper sulfate. When heated, white solid copper 2 sulfate is left and steam is given off.